Welcome to another time value of money video. Let's look at question number 8. Again, we're doing this to learn how to use our interest factors to help us solve moderately complex problems. So you desire to pay off your 360-month mortgage on the due date of your 240th payment. You desire to eliminate those last 10 years of scheduled mortgage payments. If you originally borrowed $168,600 at an annual rate of 7.25%, what is the size of the principal reduction payment that you should make on date 240? Well, there's two steps here. The first step is to determine P, the payment size, okay? And we have learned to this date that the payment amount is equal to the loan amount, $168,600, divided by the appropriate PVIFA. And here the PVIFA will be one that has an R value for R that is equal to 0.0725 divided by 12, and a value for N that is equal to 360. It's kind of that straightforward. So I'm just going to show you what this PVIFA looks like here. So this PVIFA will look like this. 1 minus 1 over 1.006041667 raised to the 360th power, all divided by 0.006041667, and that's what that is. I thought it was good to show a 7.25%, and to give you some practice working with numbers like this that are just not nice and neat. And now the value of this PVIFA is 146.5897. Alrighty, it's good to carry a whole lot of values to the right of the decimal. And, well, then we have our answer for at least for part 1. So it's 168.6 divided by 146.5897. And that answer is, the payment is $1,150.15. So there, we're done with that. Now we have to answer the question. At date 240, we're going to make our regular payment, and then at the same time we want to pay off our mortgage, which would be to pay off the last 10 years of payments all at once. But we don't just pay 10 years times 12 payments in a year, or 120 times this. That would be wrong, because money is time value. So let's see how we do it. Well, cash flow date lines are quite helpful. So there's date 0. We borrowed the 168.6. And then at date 1, we paid $11.50. I'll leave the pennies off. Date 2, we pay $11.50. All the way out to date 240, we pay $11.50. But the deal was for us to pay $11.50 at 241 all the way to 360. Right? That was the deal. But what we want to now do is we want to pay off this part of the mortgage payment stream that's required. We want to pay that off right now, all at once, at date 240. At the same time we pay this $11.50, we also want to make another payment, pay some other amount. And the question is, what is that amount? And you're probably thinking, hey, that is pretty easy. And you're absolutely right. So we need to know the remaining principal balance at date 240. And since it's a 360 payment loan, we know the payment's $11.50.15, then it's just a matter of, making use of our application formula number 4, present value of annuity equals annuity cash flow times the appropriate PVIFA. And in this case, the remaining principal balance at date 240 is the present value of the annuity that's relevant to us. The annuity that we care about is this annuity right here. Okay, it's got 120 payments. So that remaining principal balance at date 240, right after we make this payment, is the present value of the annuity relevant here. The annuity cash flow, we already know that. That's the 1150.15. And then this PVIFA is the one that will have an R value of 0.00604. That's a 0. I'll just put the rest up here, 1667. And the N value, of course, is 120. Why 120? Well, because we've paid 240 payments. We've got 120 more to go. And so the remaining principal balance at date 240 is the present value of this annuity as of date 240. And, very important, when we use this PVIFA right here, it's going to give us the value 1 period prior to the first cash flow of this annuity. The first cash flow is at date 241. 1 period prior is date 240. We're right where we want to be. We're right there, calculating the remaining principal balance at date 240. Everything matches up perfectly. That's the neat advantage of these interest factors. That's why there are several videos you studied, hopefully carefully, showing you precisely what we did algebraically to get the formulas for all these interest factors, especially these for multiple cash flow streams like annuities. Alrighty, so again, we just are going to have the RPB, the PVA is going to equal 1150.15 multiplied by this PVIFA. Now, what's it going to be? Bigger or less than 120? That's right, less. In fact, it's going to be, when you do the algebra, it's going to be 85.1781. Just to make sure you know what that formula is, I'll just remind you here, it's this formula, PVIFA, right here, is going to be 1 minus 1 over 1.00604 to the 1, that's a 4, to the 120th power, all divided by 0.00604. Okay, now I left off the digits to the right of the 4, but that's just because I ran out of space. Okay, so again, 85.1781. Then when you multiply this by this, of course, you get $97,000, $967 and about 61 cents. And so the remaining principal balance at day 240 is this. And so this is the amount that we have to pay at date 240 along with the 1150.15. Okay, and when we do that, our loan will be totally paid off. We will have prepaid the last 120 required payments, the last 10 years of required payments. And notice if you take 120 and multiply it by 1150.15, you get a number that's much bigger than what we have to actually pay off. And that's because money is time value, and that's what this is all about. And that's enough for this video. Thanks for watching.